Hello, gentlemen. What we have here is an RL series circuit. I will enter a few values. So we have a resistor and an inductor in series with each other and the power supply. Remember that the resistor and the inductor, the voltage in this case is out of phase by 90 degrees. Okay, and we can use that with a few formulas and help us out. So if this is our situation right now, I think we've got a 30 ohm resistor and a 60 ohm inductor. With that, we can figure out what the Z is in this case. For me, I would figure out Z is equal to the square root of R squared plus XL squared. Again, we would have 30 squared plus 60 squared. I grab my calculator. I have 30 squared plus 60 squared equals, and then the square root of that is 60.08. So in this case, Z is 60. I'm going to write that down right here. Z is equal to 67.08 ohms. So then I would write that in here, 67.08 ohms. Now that I know what the Z is, I can use Z and E and figure out what the current is. What's the amperage in this circuit? So the formula for IT would be IT is equal to ET divided by Z. In this case, 120 volts divided by 67.08. So 120 divided by 67.08 gives me 1.79 amps. Yeah, so IT is 1.79 amps. Great. Let's put that in here. 1.79 amps. Now what do we know about a series circuit? That in a series circuit the current is constant throughout the circuit, so I can put 1.79 amps across that resistor, through the resistor, and 1.79 amps through the inductor. So now we've got a few more values to work with, and I can start with the voltage at the resistor. What's the voltage drop across the resistor? To figure that out, I can use ER is equal to I times R, excuse me. So let's do that. ER is equal to IR times R in this case. And IR is 1.79 and R is 30 ohms. So if I take 1.79 times 30 ohms, that equals 53.7 volts. I can write in here 53.7 volts. That's how many volts were dropped across the resistor in this case. If I'm staying with the resistor, I can figure out the P real easy by multiplying the I times E. So in this case, P is equal to I times E. So P is equal to I times E, and I is 1.79, and the E is 53, what the heck is it? 53 point, I forgot to write it down, 53.7 volts. So in this case, P is equal to 96.12. 96.12 watts. So the wattage, 96.12, that would be true power. And now that we have the inductive reactance of 60 ohms and the amperage through the inductor, we can figure out what EL is. What is the voltage drop across the inductor? EL is equal to IL times XL. So IL was 1.79 times the 60 ohms. And if I grab my calculator, 1.79 times 60 equals 107.4. So EL is equal to 107.4 volts. And then we'll take a minute to write that in here. And if I'm looking for the VARS L, which is the volts amps reactive of the inductor, the VARS of this inductor, the formula for VARS would be VARS is equal to E times I. So I would write that down as VARS L is equal to EL times IL. In this case, EL is 107.4 times 1.79. And the VARS would be 1.2, VARS L would be 192.25. 192.25. Now at this point I can figure out what the L is if I'd like to, using the XL. So the formula for L would be XL divided by 2 pi F. Now, you know that if I don't tell you what the frequency is, or the problem doesn't have a specific frequency, we're going to consider the frequency 60 hertz. And by now I've told you that 2 times pi times 60, if it's 60 hertz, the frequency is 60 hertz, then 2 times pi times 60 hertz is 377. The XL in this particular case is 60. So let's figure out what 60 divided by 377 equals 0.159 henries. 0.159 henries. Those are henries. The inductance of the inductor is labeled in henries, so 0.159. We come over to this side of the problem, and I've got the VA and the power factor and angle theta to figure out. So to figure out the VA, I can use the formula, the square root formula, P squared plus VARS L squared. So in this case, the P was, I'm going to look for it here, the P was 96, I'm going to write it down here, 96.12 squared plus the VARS, I had the VARS at 192.25, so 96.12 squared plus 192.25 equals, I did that wrong, so I'm going to start again, 96.12 squared plus 100, I'm sorry, I did it wrong again, 96.12 squared plus 192.25 squared equals and then the square root of that. The VA in this case is 214.94, we're going to call that. 214.94 VA. Now if I want to know the power factor, we can use the VA, the power and the true power and the VA itself. That's one of the formulas. So let's do power factor is equal to the power divided by the VA. And in this case, the power is 96.12, and the VA would be divide that by 214.94. So 96.12 divided by 214.94 equals 0.447. We're going to call that 0.45. So that's the power factor. You have a power factor of 0.45. That's not too good. Power company's not happy about that. And if I take that number and I want to know what angle theta is, then angle theta would be 0.45, and with this Texas Instrument calculator, second cosine, it comes out to 63 degrees. Whoops, 63.44 degrees out of phase. So let me write that in here. Power factor of 0.45 and 63.44 degrees. Remember, there's more than one way to get to all of these answers. This is just the way I presented it to you. Remember, in this case, in a series circuit, the voltages are out of phase. So another formula to figure out the ET would have been ET could have been equal to the square root of ER plus EL. I made a mistake there. I want to correct that. Looking for my eraser. Thank you. Let's rewrite that. Sometimes it doesn't erase well. ET is equal to the square root of ER plus EL. Now these are both squared inside there. So it would be ET is equal to the square root of ER squared plus EL squared. There's more than one way to get to some of these answers, so just consider that. And I hope this all worked out for you. Hope the video worked, and I appreciate your time and energy. Thank you.